In this video, we're going to have a look at how to sketch a hyperbola. In the previous video, we saw that an a value bigger than 0 shows us that the hyperbola will lie in the first and third quadrant, and an a value smaller than 0 or negative indicates second and fourth quadrant. We also saw that the q value shows us the horizontal asymptote. We will now use this knowledge to sketch the hyperbola. Example: sketch the following graphs on the given system of axes and clearly indicate the intercepts with the axis. In the first example, the a value is negative, so we know that this hyperbola will lie in the second and fourth quadrant. There is no q value or a q value of 0, and this means there will be a horizontal asymptote at y is equal to 0 on the x-axis. In grade 10, the vertical asymptote is always on the y-axis or the line x is equal to 0. We can now see that this graph will not intersect the x or y-axis, so there are no intercepts with the axis to indicate. Therefore, we can choose which coordinates we want to indicate, and I prefer to indicate 2 coordinates on each part of this hyperbola. To determine these coordinates, I'm going to choose x values that can easily be substituted into the equation. The first value I will substitute will be -5, because -5 divided by -5 gives me 1, and my first coordinate will be -5 and 1. Another easy negative x value to substitute is -1, because -5 divided by -1 is simply 5. So my second coordinate will be -1 and 5. Before I move to determining coordinates on the second half of the hyperbola, it is important to also indicate the 2 asymptotes. Firstly, the one at x is equal to 0, and always add the equation, and then the horizontal asymptote will be on the x-axis at y is equal to 0. Next, I will choose to substitute 2 easy positive x values. If I substitute x with 1, I will have the coordinate 1 minus 5. And when I substitute x with 5, my second coordinate will be 5 and -1. And now we can go and draw the 2 parts of the hyperbola. Remember that when connecting these dots, this is a curve and not a straight line that moves closer to those 2 asymptotes but never touches them. In example 2, we now have an a and a q value. I prefer to always get a rough idea of what the graph will look like. And in this case, I'm going to start off with the q value. This q value indicates that there will be a horizontal asymptote at y is equal to -2. Next up, the a value, which is +4, indicates that the parts of the parabola will lie in the first and third quadrant. And then they will also move 2 units down. So in this case, it helps if you consider the cross of the 2 asymptotes to be your new system of axes, because then you will still ensure that this hyperbola lies in the first and third quadrant without intersecting these 2 asymptotes. Now we can see that this graph does have an x-intercept, and this will be the first coordinate that we have to determine. To calculate any x-intercept, by now you know that you change the y value in the equation to 0, and using algebra then solve x. First off, I'm going to take the -2 and add it on the left-hand side, and now we have the x in the denominator, which means divided by x. So now I need to multiply by x on the left-hand side to get it out from under the denominator. If I now divide both sides by 2, x will be equal to 2. This means the x-intercept is at 2 and 0. When you now start drawing your graph, it is important to always start with the asymptotes. So in this case, we have a horizontal asymptote, which now lies at y is equal to -2, and then our vertical asymptote is still at x is equal to 0. We've already determined that the x-intercept of this graph is at the point 2, 0, and because we already know the form of a hyperbola, we can now go and draw the first part. For the second part of the graph, we still need coordinates. And because the second part of the graph does not intersect with any of the axes, we can choose these coordinates, and of course we need to choose negative x values to substitute. The first value I'm going to choose is to substitute x with -4. Now we know that -1 minus 2 will give a y value of -3. Next, I'm going to choose to substitute the value of -2 in x's place, and that will give me a y value of -4. Now we have two more coordinates that we can go and plot. They will be at -4 minus 3 and at -2 minus 4, and now I can connect them to draw the second part of the graph. In example 3, we once again have a q value and this time a negative a value. Take note that the minus can be indicated in the numerator with the 3 or in front of the whole fraction. If I now first get a rough sketch in mind, I will start off with the asymptote, and that will be at y is equal to 4. Then I know that the negative indicates that the graph will be in the second and fourth quadrant. And here we can see that there will be another x-intercept that we need to determine. Again, I will do this by changing the y value to 0. And in this case, my next step will be to take the 3 over x to the left-hand side. Next, I'm going to multiply with x on the right. And finally, I will have an x value of 3 over 4. When it comes to sketching the actual graph, I'm again going to start with my two asymptotes at y is equal to 4, and then the vertical one at x is equal to 0. Next, I can indicate the x-intercept, and because we do not have an accurate system of axes, it is important that you write down the coordinate. From here, I can go and draw the first part of my hyperbola. And again, for the second part, I'm going to choose some x-coordinates. I'm going to choose to substitute x with -3 and -1. Because there's no accurate number line, I'm going to choose to first draw the neat form of the graph and then add my two coordinates of -3, 5 and -1, 7.